All right, so we're finishing up the lessons on 5.1 today. So this is going to be lesson 5.1D. And we are going to be adding fractions containing trig expressions. All right, so the first thing that we need to remember is the number one rule for adding fractions, and I'm fairly confident you guys all know that is you must have a common denominator. All right, and that's what we're going to be working with on the first example. Example 1, we're going to add and then use the identities to simplify. All right, so our first example, we have two fractions. The first one is sine of theta over 1 plus cosine of theta. And then we're adding to that another fraction that is cosine of theta over sine of theta. All right, and now what we need to do is look at our fractions and see if we can simplify, and in this case we can. So what we'll need to do is figure out what your least common denominator is. So over to the side, we're going to figure out the least common denominator. And it has to have everything both of your denominators have. So it has to have a 1 plus cosine of theta. And it has to have, I don't have a lot of room, it has to have a sine of theta also. All right, let me just rewrite that because that's kind of annoying. Okay, so I'm going to rewrite the problem, but I'm going to leave some space to change these. So anyway, I'm going to make longer fraction bars and just rewrite the problem. All right, and then I'm going to multiply by what these need to have the common denominator. And whenever I do the multiplication, to keep it legal mathematically, I have to do it on the numerator and in the denominator. So for the first fraction to have the least common denominator, I need the sine of theta multiplied by it. So what I'll do is go ahead and multiply the numerator and denominator by the sine of theta. All right, and then for our second fraction, it needs a 1 plus cosine of theta. Okay. All right, so here we go. Once we have a common denominator, I'm going to make one fraction and go ahead and write the common denominator as the denominator. Now, I'm not going to multiply it out because more than likely something is going to be able to cancel. Not necessarily, but more than likely it will. And so if we have it multiplied out, then we'd have to factor it. So let's just go ahead and leave it in factored form. Now on the numerator, I do need to multiply these. So sine times sine of theta is going to be sine squared of theta. All right, then I would need to distribute the cosine of theta. Okay. All right, now I'm going to rearrange these. Now you might be able to just keep going on this problem and not worry about rearranging them. But I'm going to put the sine squared of theta and the cosine squared of theta together. Because I know that sine squared of theta plus cosine squared of theta is just 1. And then you still have that cosine of theta left over. So this just becomes the 1. And then this comes down. And your denominator comes down as well. Okay, let me get rid of this highlight. Okay, and then I think you all recognize that we have a 1 plus cosine of theta in the numerator and denominator, so it gets canceled out. And when everything gets canceled out of the numerator, you're left with a 1 up there. And we all know that 1 over sine of theta is cosecant of theta. All right, so that, even though it started off a lot different with an addition problem, it simplified all the way down to just cosecant of theta. All right, now that we can use that reciprocal identity even when the numerator is not 1. So for example, if we have 3 over cotangent of x, so even though there's not a 1 there, there's a 3 there, it's still going to work out. So instead of being just the reciprocal, it's going to be 3 tangent of x. All right. Also, if we have negative 4 over sine squared of x, right, we can use the reciprocal identity when there's a negative 4 up there, but it's going to be negative 4. And then the reciprocal of sine squared is going to be cosecant squared of x. Okay, so that might come up in this assignment or the next few days. And then one more, if we have cosine squared of x over secant squared of x. So even though that numerator is not even a number, as long as I don't have addition or subtraction in the denominator, it's just a trig ratio to a power or not to a power, I can still use it. So I can leave the cosine squared as the cosine squared, and then I can use the reciprocal identity for the secant squared and just move it to the numerator, just like I did with the sine squared. It changed to cosecant squared when I moved it. The cotangent changed to tangent when I moved it. So the secant squared is going to change to cosine squared when I move it. All right, and then that's going to end up being cosine to the 4th of x. Right? So that can sometimes be a little bit of a shortcut. So as long as that is, by itself in the denominator, nothing is added or subtracted to it, you can bump it up to the numerator and change it to the reciprocal using a reciprocal identity. Okay, we are going to do another thing today with fractions. So for example 2, sometimes it's helpful when you're doing these problems to rewrite it so it's not a fraction. So that's the other thing we're going to practice today. So rewrite the expression so that it is not in fractional form. Okay, so what we have is cosine squared of x over 1 minus sine of x. Okay, now this was a problem we did that. I think we've already done this one a different way, but I'm going to show you a method to do this. It just works out a little differently. So what we're going to do is we're going to multiply by what's kind of like the conjugate of the denominator. Now, there are multiple ways to do these problems. So I'm just trying to show you all the different methods, like all the different things you can try. So this could come in handy, or you could just do it today and never do it again. So I just want you all to have all the skills. So we're going to multiply by what's kind of like the conjugate of the denominator. So if you guys remember conjugates, they have the same first part, but the in between is opposite. So this was the original problem. So what I'm going to do is multiply the numerator and the denominator by what's kind of like the conjugate of the denominator, which is going to be 1 plus sine of x. And this doesn't change, this doesn't change the value of the fraction because I did the same thing on the numerator and the denominator. It just changes the way it looks. All right, so now I'm going to leave the numerator like it is. But in the denominator, I'm going to multiply it out. But because they're conjugates, we can do the shortcut multiplication. So we can just do 1 times 1. And then negative sine of x times positive sine of x is going to be negative sine squared of x. All right. And then because of the way these are written and your identities you have for the Pythagorean identities, most likely this is going to give you something that we can use one of those identities to simplify. So 1 minus sine squared of x is going to be cosine squared of x. And then that cosine squared of x is going to cancel. And you're just left with 1 plus sine of x. Okay, so that's just one way to get to the answer, another method. All right, so what I want y'all to do is do the lesson 5.1D worksheet, little half worksheet. Now, if you were at the boot camp and I didn't give this to you, you don't have to print it unless you just want to. You can just work it out on a sheet of paper and then turn that in.